maybe just go, the 3D level scanner is a very unique piece of equipment. There's really nothing else on the market that does what it does, as it has the ability to measure multiple points on the surface of the material over a broad beam angle. Most of the other sensors we sell are single point devices where they're just measuring where it physically touches or where it measures within a narrow beam, but this can read the surface over, like I said, a broad beam angle. So we can take into consideration peaks and valleys in some of these larger diameter vessels. So if somebody's looking for volumetric accuracy, the 3D level scanner is really about the only product that can take into consideration the surface of the material over the entire diameter of the vessel, taking into consideration the peaks and valleys. And a lot of customers really appreciate the additional amount of information they can glean from this type of a sensor. Well, you see a lot of it really in the agricultural markets. I think that's where it probably has had its greatest impact, because often they have the larger diameter vessels, and sometimes they have multiple fill points, multiple discharge points, and there was really never a good way to know how much material you have. Yeah, they understood what a single point device could bring them, but it wasn't giving them the volumetric accuracy they were looking for. So it's particularly going to be in the larger diameter vessels in the grain industry, ethanol. We certainly see a lot of it. Cements, again, you see some of it in some of those great big cement silos that are out there. And again, like I said, it's quite unique in how the sensor operates and what it can provide.
Well, yeah, so the 3D scanner, people see it online, they see the pretty pictures, and they think, wow, that's really cool, because, I think everybody struggles with the whole geometry question of, your material sits like this after you fill, and then it turns like this, and when you're measuring to a single point on the surface, how do I really know what's in my silo? And a lot of people struggle with that. The answer for most of the industry is geometry. If we've got a single point of fill and a single point of discharge, we can generally find a good single spot to measure to that gives us a good representation of what's in the silo. So, I would say probably half of the people that come to me and say, I want the level scanner, is not necessarily the best fit for their application. Okay, Mr. Customer, you've got a 12-foot diameter silo with plastic pellets in it. That sits in a pretty predictable fashion. The level scanner really shines in applications where things aren't predictable, where you have multiple fill points and multiple discharge points, where they're really big silos, where you're pulling out of it with a front end loader, or and the material's just all over like this. In a silo like that, what point do you aim at, to give you a good representation of what's in there, or points even if you get multiple points, you don't know that it's going to be where your peak is, or those are the kind of applications that the 3D scanner really shines in. It's non-free flowing materials, so things that like just build a cliff, as it's pulling out of the silo. It's domes. Some materials are stored in flat storage domes. It really isn't a single point way to measure that. It's got to be done with something like the level scanner.
And the version of the sensor that provides the 3D graphical representation of the surface of the material available on the PC has been used by customers where they're just looking to determine how much material is building up on the sidewall, where they had something that was extremely sticky. It would build up on the sidewall, and then that sidewall would collapse, and they actually blew out the wall of a silo. So they were just looking to monitor to see how thick that buildup was getting on the side. They weren't so much concerned with volumetric accuracy. They just wanted to have the ability to see inside of that silo to know what was going on, so their situation wouldn't get critical.
Likewise, I had an interesting one where it was a 1,000,000 bushel corn bin, and occasionally they have to go inside and clean it out. Well, they had a case where somebody actually went inside of it. They thought it was empty. The material collapsed, and it was a huge safety issue. Luckily, no one was hurt in that instance, but it caused them to think, okay, we got to know when that silo is empty.
And sadly, people die in grain bins every year.
Absolutely, yeah.
So these are more for a single point.
Yeah, so really anything besides the 3D level scanner is any other instrument, whether it's a smart bob, whether it's laser, ultrasonic, radar, they're all doing the same thing. We are automating a tape measure. So we're taking a distance measurement from the face of the sensor down to the surface of the material, and from that distance measurement, we're calculating volume based on the parameters of the vessel that we put into it, and then we're calculating weight from there using a bulk density number. So, geometry and math. You know, the 3D scanner, nothing does what the 3D scanner does, no question. But it's not necessarily the right fit for every application. I tell people, you know, you're trying to hunt squirrels with an elephant gun. You know, it's not the least expensive technology on the market. It's complex. You know, I guess I'm a firm believer.
And it can't be used for process control. You would never
Right.
rely on this type of a system to let you know when your vessel is full, stop filling, or when you're empty to start filling.
Right, right. I'm a big proponent of you know, keep it simple. I like going with the simplest solution that will achieve what you're trying to achieve, and that's not always a level scanner. Right. So point level, we're talking about, do I have material at this point or not? Typically, the most common usage for that would be high and low level alarms. You know, keep from overfilling the silo, keep from running out of material. But you know, it's kind of the digital versus analog idea. You know, all that tells you is whether you have material at this point. That's really the gold standard for process control, because you have something that is physically making contact with a probe in the process before you shut down conveyors and turn things on and off and activate diverter valves and all that sort of stuff. The continuous level line is really, although some people do use it for process control, it's really designed more for inventory control, trying to manage what you have in your silos, ordering materials on time, making sure that you've got enough for your production schedule, and less about turning things on and off.
And realistic, you know, all of this equipment was really developed to keep people from having to climb on top of silos.
Mm-hmm.
You know, up until somebody came up with the idea for a plumb bob back, 150 years ago. You know, people had to climb on top of their vessels and look in, and you know, there's obviously a lot of danger associated with that, a lot of liability, plus allocating someone's time resource to doing something where they could probably be doing something a little more productive. So the level controls, whether it be point level device for high level shut off, low level startup, or the inventory management system,